Could be fun to find aliens. That would be a new form of life. So we bring biologists with us. All right. That would be discovery. I love it.
For centuries, humans have been fascinated by the moon and its secrets. But what if we told you that there is more to the moon than meets the eye? India, with its relentless pursuit of excellence and innovation, has finally uncovered something on the lunar surface that challenges everything we thought we knew about our natural satellite. This groundbreaking discovery has put NASA in a tight spot and opens a new chapter in our understanding of the moon. What did India find on the moon? And what was NASA hiding from us? Stay tuned as we delve into the astonishing revelations that Neil deGrasse Tyson has shared about India's Chandrayaan-3 mission and the implications they have for our future in space. Before we dive into the details of the groundbreaking discoveries made on the lunar surface, it's important to understand some background about the moon and its exploration. The moon, our closest celestial neighbor, has long captivated us with its mysteries, and it has been the scene of a thrilling saga of international competition and exploration. Back in 1966, a significant moment in space exploration history occurred when Luna 9, a Soviet mission, achieved the first soft landing on the moon. This groundbreaking achievement not only marked a successful touchdown, but also provided stunning panoramic images of our nearest space neighbor. Luna 9 wasn't your typical spacecraft. Shaped like a spherical capsule, its innovative design weighed 99 kilograms and measured 58 centimeters in diameter. Equipped with 4 pedals, these served a dual purpose, ensuring stability upon landing and revealing its vital instruments. Its cargo included a communication radio system, advanced solid-state radiation detectors, and a crucial thermal control system to manage temperature fluctuations. Most notably, it featured a television camera mounted on a rotating platform, offering breathtaking views of the lunar landscape. Luna 9's mesmerizing images showcased a lunar terrain of stark contrasts, with rugged craters set against undulating hills, uncharted territory devoid of human presence. These captivating images made headlines in the Daily Express newspaper after being received by the Jodrell Bank Observatory in England. However, Luna 9's mission extended beyond visual capture. It conducted vital scientific investigations, meticulously recording lunar temperature variations from a frigid -153 degrees Celsius during the night to a scorching +123 degrees C in the day. These measurements unveiled the moon's near absence of atmosphere, with pressure less than a billionth of Earth's. Luna 9 also reported radiation levels, revealing a daily dose of approximately 30 Roentgen. But it didn't stop at observation. It interacted with lunar soil, conducting a rudimentary soil mechanics experiment. The spacecraft employed a rod to exert pressure on the moon's regolith, yielding a significant finding, a bearing strength of at least 0.4 kilograms per square cm. This crucial discovery indicated that the lunar surface was sturdy enough to support potential future landers and rovers. As all good things must come to an end, Luna 9's mission ended when its batteries were depleted after approximately 3 days on the moon. Yet, during its brief time on the lunar surface, it managed to transmit 8 captivating images and invaluable data. Luna 9's remarkable journey paved the way for further lunar exploration, with Luna 13 following in its footsteps later that year on December 24th. This subsequent mission continued the legacy, conducting similar experiments and deepening our understanding of the moon. Fast forward to 1969, a monumental event unfolded, forever reshaping our understanding of space and our position in the universe. This transformative journey kicked off on July 16th, with the launch of the Apollo 11 mission from Florida's Kennedy Space Center. It was a vital part of the ambitious Apollo program, aiming to safely take humans to the moon and bring them back home. 3 incredible astronauts were entrusted with this monumental task. Neil Armstrong, the mission commander, made history by becoming the first human to step onto the moon. Alongside him were Edwin Buzz Aldrin, the lunar module pilot who followed in Armstrong's footsteps, and Michael Collins, in charge of orbiting the moon in the command module while his colleagues explored the lunar surface. Apollo 11 was a marvel of engineering with 3 crucial components. The command module, named Columbia, ensured a safe return journey to Earth. The service module provided essential resources like power, oxygen, water, and propulsion to Columbia. The lunar module, known as Eagle, had a two-stage design responsible for transporting Armstrong and Aldrin from lunar orbit to the Moon's surface and back to the command module. The Apollo 11 journey spanned about 8 days, filled with anticipation, wonder, and groundbreaking discoveries. After leaving Earth, the spacecraft rendezvoused with the Moon's orbit by July 19th, setting the stage for the next phase. On July 20th, Armstrong and Aldrin descended aboard the lunar module, touching down on the tranquil plains of Mare Tranquillitatis, also known as the Sea of Tranquility. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," marked the moment he set foot on the lunar surface. Aldrin joined him, and the two spent about 2 hours conducting experiments, collecting samples, planting the American flag, and setting up scientific instruments. Meanwhile, Collins orbited the Moon in the command module, conducting experiments and capturing photographic evidence of the lunar surface. After completing their lunar tasks, Armstrong and Aldrin rejoined Collins on July 21st. They bid farewell to the lunar module, charted their course out of the Moon's orbit, and began their journey back to Earth, successfully splashing down in the Pacific Ocean on July 24th. Apollo 11's significance went beyond the tangible. Mission data revealed critical insights, like the Moon having a faint atmosphere primarily composed of helium, neon, and argon. The lunar landscape was dominated by regolith, a fine dust layer formed by micrometeorite impacts over millennia. Despite the predominantly arid nature, hints of water ice were discovered in the Moon's permanently shadowed craters. Most importantly, the Moon's age was estimated at approximately 4.5 billion years, suggesting its formation through a colossal collision between Earth and another celestial body. Now, let's return to the present. In 2023, the world witnessed a significant milestone in space exploration as India launched its Chandrayaan-3 mission. This mission was not only a proud moment for India, but also a breakthrough for the global space community. It aimed to achieve something that no country had done before: a controlled landing near the Moon's elusive South Pole, a region many countries are eager to explore for various reasons, as explained by the famous astrophysicist Neil deGrasse Tyson. Neil deGrasse Tyson describes the Moon's South Pole as a treasure trove for science. It has craters that never see the light of day, and these craters may contain something priceless: water ice. Water is not only vital for life, it can also be converted into rocket fuel. On the other hand, it has peaks that are always bathed in sunlight, making them ideal spots to harness solar energy. But that's not all. The rocks at the Moon's South Pole are ancient, and they reveal secrets about the Moon's origin and its connection to Earth's history. However, landing in this lunar neighborhood is not easy. The South Pole is a harsh place, much more rugged than other parts of the Moon. So how did India pull off a successful landing? What were the obstacles overcome? And what were the mysteries unraveled in the lunar South Pole region? Keep watching to find out. The Chandrayaan-3 mission consisted of 3 essential components, each with specific tasks. The orbiter was the vigilant observer from above, equipped with 8 advanced scientific instruments. Its role was to study the lunar surface and atmosphere from a circular orbit situated approximately 100 kilometers above the Moon. Along with the orbiter was the lander, named Vikram, in honor of Dr. Vikram Sarabhai, the visionary founder of the Indian Space Research Organization, ISRO. Vikram was more than a symbolic tribute. It was a robust workhorse furnished with 4 instruments to collect data on temperature variations, seismic activities, plasma density, and surface composition at its designated landing site. Last but not least, Pragyan, the rover, lived up to its Sanskrit name meaning wisdom. As it traversed the lunar terrain, Pragyan's 2 onboard instruments diligently unraveled details about the Moon's mineralogy and the elemental composition of its soil. The journey began on July 14, 2023, with the launch vehicle Mark III, or LVM-3 rocket launching Chandrayaan-3 from the Satish Dhawan Space Center in Sriharikota, India. However, the mission wasn't a straightforward shot to the Moon. Instead, It engaged in a meticulous orbital dance around Earth for over a week, gradually building the required momentum. On July 21, 2023, Chandrayaan-3 entered the next phase of its mission by executing a precise trans-lunar injection maneuver, aligning itself for capture by the Moon's gravitational field. This maneuver transitioned it into an elliptical orbit around the Moon. The ISRO team continued to refine the spacecraft's trajectory through a series of carefully executed orbit-raising and orbit-lowering maneuvers in the subsequent weeks. Their goal was to position Chandrayaan-3 in an optimal circular orbit, maintaining an altitude of approximately 100 kilometers from the Moon's surface by August 19, 2023. This intricate objective had been successfully achieved by August 23, 2023. After the complex orbital maneuvers of Chandrayaan-3's orbiter around the Moon, the time came for the lander, Vikram, to embark on its daring descent towards the lunar South Pole. Detaching from its parent orbiter, Vikram faced the formidable challenge of touching down on the lunar surface, akin to walking a tightrope descending from space toward a celestial body. Touching down on the lunar surface is a formidable task. Vikram had the critical mission of reducing its speed, which was initially a brisk 1.68 kilometers per s. Using its onboard thrusters, the lander carefully decelerated, coming to an almost complete standstill. But the challenge went beyond speed as Vikram approached the Moon. It had to make precise adjustments to its trajectory and orientation, much like a pilot making last-minute corrections during landing to ensure a safe touchdown. For all aboard, Vikram executed this with exceptional precision, nestling itself between two lunar craters, Silius N and Manzin C. This specific region was known for its extreme temperatures, dropping to a bone-chilling -240 degrees C, with sunlight being a rare commodity occasionally touching the lunar surface. After its successful landing, Vikram wasted no time. The lander smoothly deployed its solar panels, stretching out like wings after a long flight. It also extended its antennas, establishing a communication link with the orbiter above, and thereby connecting with the researchers and scientists on Earth eagerly awaiting any tidbits of information. But the lunar surface mission was only just beginning. After allowing a brief period for the moon dust to settle, similar to waiting for dust to settle after a gust of wind on Earth, the rover, Pragyan, was given the green light. Emerging from Vikram's ramp, the rover appeared like an explorer setting foot on an untouched island. Pragyan had a lunar day, equivalent to a fortnight on Earth, to accomplish its mission. Designed to travel up to half a kilometer from its parent lander, the rover embodied autonomy with onboard cameras and sensors. Pragyan possessed the vision and instincts to navigate the rocky and unpredictable lunar surface, ensuring it didn't stumble over obstacles or become trapped in challenging terrain. India's Chandrayaan-3 mission not only marked a historic milestone into the uncharted territory of the Moon's South Pole, but also did so with remarkable financial efficiency that left many astounded. With a tight budget of just $74 million, Chandrayaan-3 showcased India's capability to marry cost-effectiveness with advanced space innovation. To comprehend the financial aspect, let's delve into the numbers. As disclosed by the former chairman of ISRO, K. Sivan, the mission's total expenditure was approximately 615 crore rupees, which equates to roughly $74 million. Within this budget, the expenses for the lander, rover, and propulsion module amounted to around 215 crore rupees, while the launch services incurred an expenditure of approximately 365 crore rupees. This efficient budgeting was particularly commendable when compared to the preceding Chandrayaan-2 mission, which, despite its unsuccessful landing in 2019, had a significantly higher budget of 978 crore rupees, or $96.5 million. Moreover, when Chandrayaan-3's budget is contrasted with other international lunar expeditions, its cost-effectiveness becomes notably evident. For instance, Russia's Luna 25 mission, which aimed for the same lunar South Pole but met with an unfortunate crash, had a budget nearing $2 million. NASA's ambitious Viper rover project, scheduled for 2024, was projected to cost a substantial $433 million. China's Chang'e 4, which successfully landed on the Moon's far side in 2019, carried a price tag of around $180 million. One might wonder what contributed to Chandrayaan-3's budget-friendly success. A significant part of the answer lay in the mission's compact design. With a combined weight of only 1.4 tons for the lander and rover, Chandrayaan-3 was considered considerably lighter than many of its international counterparts. A notable comparison is NASA's Viper rover, which alone weighed approximately 1 ton. This strategic lightweight design reduced various associated costs, especially those related to launch and fuel. However, weight was not the sole advantage. Chandrayaan-3's financial efficiency was also attributed to its prudent use of existing technology. India had the GSLV Mk3, its most robust rocket, at its disposal, a launcher previously employed in several successful missions. Moreover, instead of starting from scratch, the lander and rover for Chandrayaan-3 were adapted and enhanced from the designs used in Chandrayaan-2. Now let's delve into what this lunar success means on a broader scale. India's triumphant entry onto the lunar stage has the potential to elevate its position in the global space race, particularly in the Asian space community. It solidifies India's standing as a formidable space power, potentially positioning it ahead of countries like Japan and South Korea and placing it just behind China in the grand cosmic race. India's Chandrayaan-3's recent voyage to the moon's south pole has unearthed numerous unexpected revelations that challenges what we thought we knew about the moon. But first, it's crucial to understand that certain parts of the South Pole receive near constant sunlight, making them an indispensable hub for energy generation and communication during lunar missions. Given the magnitude of this endeavor, the equipment utilized had to be nothing short of exceptional. Starting with Vikram, the lander, which housed an invaluable lunar surface thermometer known as CHASTE. This device took the moon's temperature readings throughout the day, constructing a thermal map around the South Pole. Such data was crucial because regions with low enough temperatures could be hiding water ice. Additionally, Vikram was equipped with a laser retroreflector array, LR. This nifty tool bounced laser signals off orbiting spacecraft or telescopes back on Earth. This interaction wasn't just for communication, it allowed scientists to measure distances on the moon and delve into the mysteries of lunar gravity and its rotation. Then there was Pragyan, the rover, an explorer armed with cutting-edge tools. It carried a laser-induced breakdown spectroscopy, LIBS, and an alpha particle X-ray spectrometer, APXS. The LIBS wielded a laser that could turn a minuscule amount of lunar soil into vapor, and then analyze the emitted light to understand the soil's composition. On the other hand, the APXS identified elements in the soil from oxygen and magnesium to rarer ones like titanium and chromium. Together, they searched for hints of water by detecting elements like hydrogen and carbon. But Pragyan wasn't just about soil and elements, it had eyes in the form of a stereo camera, also known as SCAM. This camera clicked high-resolution snapshots of the moon's landscape, aiding in navigation and spotting obstacles. More than that, it rendered the surface in 3D, helping identify the best spots for sample collection and in-depth analysis. The treasures unearthed during this mission were nothing short of extraordinary. Pragyan made a surprising discovery. It stumbled upon sulfur near the South Pole. This element was not usually found on the lunar surface. This raised intriguing questions. Could sulfur indicate the presence of water ice or other volatile substances nearby? But sulfur was not the only element Pragyan found on the moon. The rover also detected several other elements, such as magnesium, aluminum, silicon, calcium, titanium, iron, and sodium. Neil deGrasse Tyson explained that these elements were crucial for understanding the moon's geological history and evolution. Moreover, Pragyan searched for hydrogen, a sign of water. Finding water at the South Pole was vital for future missions. This water could be a valuable resource, providing fuel for rockets and spacecraft, as Neil deGrasse Tyson pointed out. Vikram also sent back fascinating data. It measured the temperatures around the South Pole, which ranged from a freezing -156 degrees C at night to a scorching 121 degrees C in daylight. These insights were essential for understanding how water ice and other resources could survive in these extreme conditions. Meanwhile, back in 2019, India was gearing up for its Chandrayaan-2 mission, which aimed to leave a lasting impression on the lunar landscape. Neil deGrasse Tyson was excited and optimistic about the mission. He shared his thoughts with the world, highlighting the importance of the mission. He said that Chandrayaan-2 was a remarkable achievement. It would make India the fourth nation to soft land on the moon, following the USA, Russia, and China. What made Chandrayaan-2 unique was its ambition to explore the moon's south polar region. Tyson's words resonated with many who eagerly awaited the mission's success. However, space exploration is inherently difficult and unpredictable. The Chandrayaan-2 mission faced a devastating setback when its lander lost contact with Earth during its final descent phase, leading to its unfortunate crash on the moon. The world felt India's disappointment, but Tyson's voice offered encouragement and motivation. He wisely remarked that space endeavors were inherently challenging, and setbacks were not the end but a push to try again with renewed vigor. 4 years later, in 2023, India rewrote its lunar story. Armed with lessons from the past and an undeterred spirit, the nation launched Chandrayaan-3. This time, the mission was a triumph, achieving what had eluded it 4 years earlier, a successful landing near the elusive and unexplored south pole of the moon. While the success of Chandrayaan-3 is yet to elude us, Indian Space Research Organization, ISRO, is now setting its sights on the next big step in space exploration, the Chandrayaan-4 mission. This will mark India as a front-runner in space exploration. Chandrayaan-4 is a planned lunar mission by India and Japan, which aims to explore the presence and usability of water on the moon's south pole. Unlike its predecessors, Chandrayaan-4 is expected to bring back lunar samples to Earth. The mission is also known as LUPEX, which stands for Lunar Polar Exploration Mission. It is expected to launch no earlier than 2026, using Japan's H-3 launch vehicle. This mission is expected to be more complex than its predecessor. Where Chandrayaan-3 had a rover of 30 kilograms, Chandrayaan-4 plans to land a massive 350 kilograms rover. The challenge increases as the mission aims to perform a precise landing on the moon's rim, an area yet to be explored. The rover will have an exploration area of 1 kilometer x 1 kilometer, significantly larger than Chandrayaan-3's 500 meters x 500 meters. The rover will be equipped with various scientific instruments, such as a spectrometer, a radar, a camera, and a drill. The spectrometer will analyze the chemical composition of the lunar soil and rocks and detect any traces of water or ice. The radar will penetrate the surface and subsurface layers and map the structure and distribution of water and ice. The camera will capture high-resolution images of the terrain and the rover's surroundings. The drill will collect samples from different depths and store them in a container for later retrieval. The mission will also have a lander and an orbiter. The lander will carry the rover and provide power and communication. The orbiter will orbit around the moon and relay data between the lander and the Earth. The orbiter will also have its own scientific payload, such as a thermal infrared imager, a laser altimeter, and a synthetic aperture radar. The thermal infrared imager will measure the temperature and thermal properties of the lunar surface. The laser altimeter will measure the topography and elevation of the lunar surface. The synthetic aperture radar will map the surface and subsurface features and detect any signs of water or ice. The Chandrayaan-4 mission will not only advance our scientific knowledge of the moon, but also pave the way for future human exploration and utilization of lunar resources. It will also strengthen the collaboration and friendship between India and Japan, two of the leading spacefaring nations in the world. In light of this, it's important to appreciate the wonders of space exploration and India's monumental contribution to our understanding of the cosmos. Thanks for watching, fam! For a more thrilling video, check out the next video that pops on your screen. You'll be stunned.